What kind of equation is this? Linear. It's a linear equation. Because both the exponents of x and y are both what number? 1. They're both 1. So to graph this linear equation, we need at least 2 points. And the graph we're going to get is going to be a line. Now we're going to do this one. We're going to do this one here using intercepts. So remember, the X-intercept is where the graph crosses the X-intercept is where the graph crosses the X-axis. The Y-intercept is where the graph crosses the Y-axis. So if I want to find the X-intercept, I'm going to let y equals 0. To find the Y-intercept, you're going to let x equals 0. Now in this particular case, it's easier to find the Y-intercept first. So let's go ahead and find the Y-intercept first. To find the Y-intercept, you're going to let x be 0, right? So you get y equals 3 halves times 0 plus 6. What's 3 halves times 0?
0.
And 0 plus 6 is 6. So now you on the worksheet it'll say Y-intercept with a blank. If it doesn't say anything about an ordered pair, then you can just put what number here? 6. If it says an ordered pair, then you have to say, in parentheses, you have to say what? 0, 6, because x is 0, so x has to be 0. All right, so there's your Y-intercept. To find the X-intercept, you let y equal 0. So if y is 0, this time this is what? 0. So you get 0 equals 3 halves x plus 6. Now remember, you have to get x by itself. So what's the next step? How do you solve this equation for x?
You subtract 6.
Subtract 6 from both sides and then combine like terms. What's 0 subtract 6?
Negative 6.
You get negative 6 equals 3 halves x, right? This is 0. All right, now to get x by itself, I'm going to go ahead. Right now, you see I'm dividing by 2. 3 divided by 2, so I'm dividing by 2. What's the opposite of division? Multiplication. So I'm going to go ahead, and multiply both sides by 2. So what you do to one side, you do to the other. What is 2 times a negative 6? Okay. These 2's divide out. And so what term is left on the other side? 3x. So I get 3x. And finally, how to get x by itself? Divide both sides by 3. So 3 divided by 3 is 1. 1 times x is x. So what is my x-intercept? Negative 4. So again, on the worksheet or test, I'll have x-intercept blank, and you can put what number here? Or if I asked for an ordered pair, you would have to put what 2 coordinates? Negative 4, 0? All right. Okay, and so then you plot those 2 points and draw your line. All right, so we're going to plot those 2 points. And so I have 0, 6, which is on the positive y-axis. And then negative 4, 0, which is here. Remember, if I say label, go ahead and label the points. And then you draw your line with your arrows. All right, so there's the line. Y equals 3 halves x plus 6. Okay? All right, let's look at this one. Suppose I had this equation. So the next one, let's suppose it was y equals negative 5/3 x plus 5. And let's do this one. So let's graph this one using a t-table instead. So when graphing using a t-table, what number do you think you would always want to use for x? 0. So if x is 0, I get y equals negative 5/3 times 0 plus 3. And in fact, when you let x be 0, what intercept are you finding? The y-intercept. So in this particular case, I am finding the y-intercept because I'm letting x equal 0. So remember, order of operations, I have multiplication and addition. I do multiplication first. Negative 3/3 times 0 is 0. 0 plus 3 is 3. So plot the point 0, 3. All right, and then remember, make things easy on yourself. Don't use any. Don't end up dealing with fractions or decimals if you don't need to. So be strategic here. What numbers for x are you going to choose? Numbers that are what? Divisible by the denominator. What's the denominator? 3. So like 3, negative 3, 6, negative 6, 9, negative 9, and so on. But always let x be that denominator. It makes things a lot easier for you. So 3 and negative 3, right? So if x is 3, I get y equals negative 5/3 times 3 plus 5. What's negative 5/3 times 3? Yeah, so remember the 3's divide out. So the 3 divided 3 is 1, 3 divided 3 is 1. And what's negative 5 times 1? Negative 5. But what's negative 5 plus 5? 0. Well, think about that. Okay, now remember, this time y is 0. Well, if y is 0, what is it I've just found? No, if y is 0, you found the what? The x-intercept. You just found the x-intercept. So remember, this was a y-intercept. This is the x-intercept. Because you just found that y is 0.
Excuse me, how you found the 0?
How to find the 0? You mean this 0?
Yeah, no, the first one.
Because anything times 0 is 0. Negative 5/3 times 0. X is 0.
Okay, if x is 0, negative 5 over 3, all will become 0, right?
Because you're multiplying by 0.
Right.
Anything
And
times
then
0 is 0.
Where that 3 came from?
Oh, that's supposed to be
From
5. You know, the sad thing is, I did that in the first class.
I was wondering.
I did that in the first class, and I don't know why. I don't have my glasses on. I think that I'm just going to blame it on that. So that's 5. All right. Okay, so 0, 5, right? And I did the same thing in the first class. Huh. All right. See the senility or old age or all of the above. All right, if x is negative 3, I get y equals negative 5/3 times negative 3 plus 5. All right, now we multiply first. 3 to 3 is 1. 3 to negative 3 is negative 1. Y'all agree? Okay. What's negative 5 times a negative 1? That's negative 1. And what's 5 plus 5? 10. So I get negative 3, 10. All right, and then you just plot that point. And there's a back page if you need to use the back page. All right, so 0, 5 is right here. 3, 0 is here. And negative 3, 10 is here, right? Now, remember how I had made that error at first? I had a 3 right here. Now, I would have gotten all these others correct because I put 5s here, but I put a 3 here. I knew something would have been wrong because when I plotted those 3 points, what would have happened?
It wouldn't have been
They would not have been on the same line. Okay. All right. All right, and then you just make sure you draw the line. Don't just say that's your graph. Because remember, a line has how many points on it? An infinite number. Okay, so these are 3 solutions, but there's an infinite number of solutions. So you got to draw your line to indicate that all of these are solutions. Don't forget to draw your arrows. So this is y equals negative 5/3 x plus 5. Okay? All right. Now, let's look at this. I have y equal x squared. Y equal x squared. Okay. Is this a linear equation? No, it's not a linear equation. Because you know a linear equation, both the exponents of x and y have to be what number? 1. The exponent of x here is 2. The exponent of y is 1. So it's not linear. Do you remember what kind of equation this is? Huh? Okay. Quadratic. Quadratic. So this is a quadratic equation. Next semester in college algebra, you're going to do a lot more with graphing quadratic equations. All we're going to do in here is just the simple kinds. Next semester is where you do a lot more with it. And there are some formulas involved for finding the vertex, axis, symmetry, and all that.
You teach the next one?
Mm-hmm. Okay. Now, when we do this one, I'm going to do this one using a t-table. And then we're going to talk about some terminology that we're going to use to help us graph variations of this. Keep in mind, though, that y equal x squared is quadratic function, quadratic equation, but we're also going to refer to it as the parent function. So just keep in mind that this is going to be the parent function. Parent function. Now I'm using the word function. Unless you remember something from a previous course, you don't have to know what a function is right now. We're going to talk more about functions next class period. We're going to talk about the definition of a function and so forth. That'll be next class period. So y equal x squared is a parent function. Y equal x squared. And you guys, as we go through this, you're going to see what I mean by parent function. So I'm going to use the t-table for the first one. So here's the x values I'm going to use. I'm going to let x be 0. So if x is 0, notice what we get. We get y equal 0 squared. But what's 0 squared? 0. So I get the origin. All right, then I'm going to let x be 1. If x is 1, I get y equal 1 squared, which is 1. All right, before I go on, let's kind of remember something from a previous course. We remember from a previous course that there is a difference between this, negative 3 squared versus, in parentheses, negative 3 squared. Those are two different things. Here, that I'm circling right here, what's the base? Negative 3. The base is negative 3. So negative 3 squared means negative 3 times itself, which gives me what? Negative 3 times negative 3 is what? Positive 9. Positive 9. Over here, if there's no parentheses, what is the base understood to be? 3 only. So this 3 right here is being squared. What's 3 squared?
9.
So this becomes a negative 9. So there's a difference between the two. So as we go through this, I'm going to use parentheses with some of these. Notice I didn't put parentheses here. It wasn't needed, although I could have said y equals in parentheses 1 squared. It would have been the same thing, right? 1 squared is still 1. If x is negative 1, I get y equals. Now, do I need parentheses this time? Yes. Because remember, there is a difference between this. Those are two different things. So what's a negative 1 squared?
Positive 1.
Positive 1. If you had written this, if you had said y equal negative 1 squared, then mathematically that's not a 1, that's a what? This is a what? Negative 1. So you know you did something wrong because it's actually supposed to be what kind of 1? Positive. So make sure you use parentheses. So use parentheses. If x is 2, I get y equal 2 squared, which is 4. If x is negative 2, again, y equals negative 2 squared in parentheses, which is what? Positive 4, right? Negative 2 times negative 2.
It's still 4.
If x is 3, I got y equals 3 squared, which is 9. If x is negative 3, I get y equals negative 3 in parentheses squared, which is 9. And as we plot those points and draw the graph, we're going to talk about symmetry. So we're going to mention the word symmetry here. So the idea of symmetry is going to get you through the variations of these quadratic equations. All right, so go ahead and plot those points. Plot those points. So 0, 0 is the origin. And I'm not going to label because it will look too messy with all these points there. 1, 1 is here. Negative 1, 1 is here. 2, 4. Negative 2, 4. And 3, 9. And negative 3, 9. All right, so I plotted the points. So I think those are 7 points. I found 7 solutions, but there are how many solutions to this equation? An infinite number. So you got to draw your graph. Now when I draw the graph, notice that it's not a line. All right, but it looks like a curve, and it looks kind of like a U, right? Kind of like this. Just do the best you can with drawing this curve. And it just keeps on increasing like this. And then do the same thing on the other side. There should be, with quadratic equations, there should be some symmetry involved to make it look symmetrical. It should be symmetrical. Okay? Should look symmetrical. So something like that. You see this, now let me talk about the name of this shape. So when you have a quadratic function, a quadratic equation, the shape is called a parabola. So this is a parabola. So the shape is a parabola. P-A-R-A-B-O-L-A. So the shape is a parabola. So notice that this particular parabola opens up. The arrows are pointing up. So we say it's opening up. You're going to learn more about the idea of opening. You're going to do more with that next semester. It can also open down, though. I mean, this parabola, I could have a quadratic equation which the parabola opens down. So it could open up or it could open down. Open up, open down. But notice in either case, you see that in this one where it opens up, that the lowest point on the graph is this right here?
Mm-hmm.
And the highest point on the graph here is this one?
Mm-hmm.
That's the highest point. So the lowest point or the highest point, and this would be called a minimum. This would be called a maximum. But the minimum and or the maximum is called the vertex. So that's your vertex. So these are vertices. So the lowest point on the parabola or the highest point on the parabola is called the vertex. So when you graph a quadratic function, a quadratic equation, the simple kind, this is a simple kind. And you can learn again how to graph the more difficult ones later, but regardless, simple or the more difficult kinds later on, one of the first things you're going to do is you're going to ask yourself, what's the vertex? So when we graph the variations of this, we're going to look for the vertex first. The vertex. Once you find the vertex, then the rest of the points follow along. Keep in mind though, see this vertex right here? So once you find the vertex, what's going to happen is this. Once you find the vertex, you're going to plot 2 points to the right and then 2 points to the left, and then you draw your graph. So always find your vertex and then 2 to the right, 2 to the left. And when we do these, we're going to use the idea of symmetry. The idea of symmetry. All right, now this is y equal x squared. Y'all agree? Which is also called our parent function. Our parent function. All right, now let's graph y equal x squared minus 5. This I'm going to call it this though. I'm going to call it f of x equal x squared minus 5. And the reason I'm using f of x, and you probably don't remember what that means, but the reason why I'm calling f of x is because in my math lab, when you get to that section, and it's not assigned yet, but when you get to that section, they're going to use f of x. Now that's function notation. Function notation. It's going to become a little bit clearer next class period what function notation is. But this is function notation. So function notation looks like this. F of x, g of x, k of x, things like that. H of x. Each of those, though, f of x, g of x, k of x, h of x, they all stand for the letter y. So instead of saying f of x equals x squared minus 5, I could also say what? Y equals x squared minus 5. And then it looks like the previous problem. But you're going to see more what you can do with that f of x in the next class period.
So it'll always equal 1.
Yes. All right. Now, I'm going to go ahead and use a t-table again. And then the next set of problems we'll do differently. So let's use the t-table on this. I'm going to use the same values for x. I'm going to say 0, 1, -1, 2, -2, 3, -3. I'm going to use the same values for x. But then once we do that and once we have our discussion, then we're going to talk about it a little bit differently. So if x is 0, wherever you see the variable x, I plug in 0. So if x is 0, I get y equal 0 squared minus 5, which is what?
0.
Which is -5. Okay. If x is 1, I get y equal 1 squared minus 5, which is 1 minus 5, which is what? -4. If x is -1, remember you got to put that in parentheses, I get y equals -1 squared minus 5. What's -1 squared? And 1 minus 5 is -4. If x is 2, I get y equal 2 squared minus 5, which is 4 minus 5, which is -1. If x is -2, parentheses, I get y equals, in parentheses, -2 squared minus 5. What's -2 squared?
4.
And 4 minus 5 is -1. If x is 3, I get y equals 3 squared minus 5. What's 3 squared? 9 minus 5, which is 4. If x is -3, I get y equals -3 squared minus 5. -3 times itself is 9. And what's 9 minus 5? 4. Okay. So I'm going to plot those ordered pairs. And I want you to go ahead and put on the same graph paper as the one you just did, so we can have that discussion. So you can see the similarities. Right. So I'll plot the point 0, -5, which is here. Then 1, -4, which is here. And then -1, -4, which is here. And then 2, -1, which is here. -2, -1, which is here. And then 3, 4. 3, 4. And then -3, 4. And then remember the shape is called a parabola, so you draw your parabola. Do the best you can with drawing this parabola. Make it look like a parabola though. And make it look symmetrical. And so you get something that looks like that. Okay? Remember this right here is the graph. Y equal x squared minus 5. X squared minus 5. Okay? Now, remember, y equal x squared is called the parent function, right? Okay, so I have this transparency, and I'm gonna, and here's what I want you to remember. For the parent function, what's the parent function? What's the equation of the parent function? Y equal x squared. Where's the vertex for the parent function located? At the origin. So in your mind, you have this. You have that blue graph right here. So that's your parent function. So just think about a parent and offsprings. So from this parent function is going to produce this offspring right here, x squared minus 5. To do that, though, I have to shift the graph which way? Down 5. So notice down, see this down, -5. Down 5. So my vertex is no longer the origin. So in your mind, you think it's at the origin, is being shifted down. So the vertex is now 0 what? -5. So 0, -5. So your vertex right here is 0, -5. That's your vertex. So when we do the rest, we're going to talk about vertex. Well, from the vertex, so notice I use the t-table, right? And that's how I did this. But what I want you to think about is this. All right, you know how to find the vertex. The vertex, it was shifted down 5, so the vertex is 0, -5. Once you find the vertex, we pick 2 points to the right, 2 points to the left. And we plot those points and we draw the graph. So we use that idea. Okay? All right, now, let's look at this one. Suppose I had this. Suppose I had y equal x squared plus 4. Y equal x squared plus 4. All right, now, let's go back to x squared minus 5 for a moment. So what was the parent function? Y equal x squared. So I have the parent function, and that parent function, I am subtracting 5 from it, right? So that subtract 5, that constant is on the outside of x squared. Y'all agree it's on the outside? X squared, and then minus 5. So that's going to be a vertical shift. Whenever the number's on the outside, that's a vertical shift. It is very simple to determine which way you go because I have my parent function, I'm shifting it down 5. Minus 5 means down 5, right? Here, I have my parent function, and I'm doing what to it? Adding 4. So that means I'm going to shift it where? Up 4. All right, so let's think about this. Let's think about what the vertex then would be. All right, so for the parent function, where's the vertex understood to be? At the origin. So in your mind, you have that origin there, and then you're just shifting it which way? Up 4. So what's the vertex? 0, 4. Very good. So the vertex is 0, 4. So this is a vertical shift. And so the vertex then will be 0, 4. Once you find the vertex, here's what you do. It's very simple. Watch what you do. So I found the vertex. The vertex is 0, 4, right? You plot it. Here's the vertex. And all you do is find 2 points to the right, 2 points to the left, and use symmetry to help you. all these problems are symmetric about this axis of symmetry. You have no idea what an axis of symmetry is or how to find it? Now, these are easy to find, though, but later on they become more complicated, and that's next semester, where there's a formula for that. All right, so all I need is 2 more x values to the right and then 2 more x values to the left. That's all you need. So give me another x value that's to the right of this point. 1. What's another x value? 2. Someone else could have chosen what? 3, whatever. It does not matter, right? I just needed 2 more. And I would just go ahead and choose 1 to the right and then 2 to the right. All right, now notice what you're going to do. So I found my vertex, so there's my vertex. So x is 0, right, for the vertex? So then you're going to say, all right, I'm going to let x be 1 this time. All right, well, if x is 1, let's figure out what it is. If x is 1, I get y equals 1 squared plus 4. What's 1 squared? 1 plus 4 is 5. Okay? All right, so I plot the point 1, 5. I plot the point 1, 5. Now let's go back and look at this for a moment. Let's look at this idea of symmetry. You see right here when this is a vertex, right? And I went 1 unit to the right and I got this y value. If I go 1 to the left, isn't the y value the same?
Yeah.
Here, if I go 2 units to the right, I got this y value. If I go 2 units to the left, don't I get the same y value? So the idea of symmetry. Over here, if I go 1 unit to the right, I get this y value right here, right? If I go 1 unit to the left, don't I get the same y value? All right, use the idea of symmetry. It helps.
So you saying when you get a problem, you necessarily don't have to solve it. You just put the point.
Well, you still have to do something to find out what that y value is. I mean, are not still using a t-table? Okay. All right. So, but what I'm saying is, once you find this one, apply the point 1, 5. So I went 1 unit to the right, correct? All right. Now I'm going to go 1 unit to the left. Well, if I go 1 unit to the left, what should that y value be then? The same as the other one. What's that y value? 5. That's what I'm saying. Now you can check yourself by looking at that x value. What was this x value right here?
-1.
-1. So if I plug in -1 for x, I better get what y value? 5. So I get y equal, in parentheses, -1 squared plus 4. What's -1 squared?
1.
1 plus 4 is 5. And that's what we're supposed to get. So notice when you go 1 to the right, 1 to the left, you better get these y values the same. All right, let's go 2 to the right instead. So if I go 2 to the right of the vertex, what's my x value? 2. So to use the t-table, if x is 2, I get y equals 2 squared plus 4. What's 2 squared?
4.
4 plus 4 is 8. So I plot the point 2, 8, 2, 8, and that's what I get. Use the idea of symmetry. All right, if I went 2 units to the right of the vertex, I went 2 units to the right of the vertex, and got my y value to be 8, then if I go 2 units to the left, it also better be what? It also better be 8. And you can check. So this time x is what, -2? So if x is -2, I get y equals, in parentheses, -2 squared plus 4. -2 squared is 4. 4 plus 4 is 8. Right, and that's all you do. And then you just draw your parabola. Just make it look like a parabola. Do the best you can with making it look like a parabola. Make it look symmetrical, though. Make it look like it has some symmetry.
So basically this idea, like this way, it gives you the idea that if you get one point like 2 and 8, the other negative x and y must be the same. If it is not the same, then you made a mistake.
That's only true if the vertex is on the y-axis. You're going to see in a little while. But you have the general idea, but that part's only true if the vertex is on the y-axis.
Okay.
Okay. All right. So if the numbers on the outside of x squared is what kind of shift? Vertical. It's a vertical shift. The numbers on the outside. Okay? So remember that. We'll come back. We're going to put some things together, but it'll be on the outside. So basically, if this was my parent function, or this is my parent function. So here's my parent function, x squared. To get the offspring was I was adding what, 4 to it. So to get 4, I just would shift it up what, 4 units, and it overlaps. See the overlap? All right. So this right here is y equals x squared plus 4. Okay. All right. Now I want to look at this one. I want to look at this one, and then we're going to compare the difference between what I'm about to do with the one we just did. Suppose I had this, y equal x plus 4 squared. X plus 4 squared. Notice the difference between this one and the one we just did. See, there's a difference, right? They look different. So in the one we just did, we had the parent function, x squared, and I was adding 4 to it. So that 4 was on the outside of what was being squared, right? Mm-hmm. Here you see a 4 that's located where? Inside. So outside is going to be a vertical shift. Inside is going to be a horizontal shift. So this is going to involve a horizontal shift. So that's going to involve a horizontal shift because it's on the inside. If the number's on the outside, it's vertical. So the inside would be horizontal. Now, I'm going to go ahead and do this one using a t-table. Now, don't worry about where I'm getting those numbers from. I'm getting to the point where I wanted you to think about how to find the vertex, though. All right, so don't worry about where these come from.
When is it vertical and when's it horizontal?
Say again?
When is it vertical and
When's it vertical? When the number's on the outside. Horizontal, you see the numbers on the inside? You have that parentheses? That's horizontal. Okay? All right, again, don't worry about where I'm getting these x values from. Just write them down. All right, if x is negative 4, I get this. I get y equals negative 4 plus 4 squared. What's negative 4 plus 4? And 0 squared is 0. Okay? If x is negative 3, I get y equals negative 3 plus 4 squared. What's negative 3 plus 4? And what's 1 squared? 1. If x is negative 2, I get y equals negative 2 plus 4 squared. What's negative 2 plus 4? And 2 squared is 4. If x is negative 5, I get y equals negative 5 plus 4 squared. So that's negative 1 squared, which is positive 1. So notice these y values are positive 1s right here. You're gonna remember the idea of symmetry in a little while. If x is negative 6, I get y equals negative 6 plus 4 squared. What's negative 6 plus 4? And what's negative 2 squared? Positive 4. Notice these two y values here are positive 4. So I'm going to plot those points, and as I'm plotting, listen to what I'm saying as I go through this. And I'm going to go ahead and, well, I'm going to use new grid paper. So if you need grid paper, there's a bunch of them over there. So notice what I have. I have negative 4, 0 right here, right? Then all of a sudden, I'm going to plot the point negative 3, 1, which is here. And then I'm going to go ahead and I'm going to plot the point negative 5, 1, which is here. So far I have 3 points. I think you can tell me that this point that I'm pointing to is probably going to end up being which point? The vertex. That's what this will be. This will be the vertex. All right, and it will be. So if you do the rest of them, let's see, we had -2, 4, and then we had -6, 4. All right, now let's kind of review a couple of things. So we found the vertex, right? So from that vertex, just like we did the previous problem, from that vertex, I went 1 unit to the right, -3 for x, and I got my y value to be what number? 1. I go 1 unit to the left, my y value better also be what? 1. Okay, my vertex, I went 2 units to the right, x -2, and I got my y value to be what number?
4.
I go 2 units to the left, -6, and I get my y values still better be what? 4. Okay. Then I draw my graph, and the graph is called a parabola. The shape is a parabola, and I get this. So that happens to be y equal x plus 4 squared. All right, now I'm going to remember your parent function. It has what equation? What's the equation of the parent function? Y equal x squared. So you know that y equal x squared has the vertex at the origin, so that's right here. So to get the offspring, I have to go which way this time? To the left. How many units? 4. Okay, that's what I get. So this is when I go left or right, that's called a horizontal shift. Horizontally. When you go up or down, that's called a what? Vertical shift. A vertical shift is easy to remember because if it's x squared plus 8, then you would go what? Up 8. If it's x squared minus 10, then you would go down 10. The horizontal shift is counterintuitive. See this plus 4? Most people think, all right, I'm going to go to the right 4. No. You do the opposite of what you see. Now, you can understand why that's true when you have a firmer foundation on what functions are, and that idea will become clearer next semester. But for now, think, if it's a horizontal shift, think counterintuitive. So you see that plus 4? You actually don't go to the right 4, you go to the what? Left 4. So if my vertex was, in your mind, your vertex at the origin, you go to the left 4, it's still on the x-axis, right? If you're still on the x-axis, my y value is still what? 0. But what's my x value? If I go to the left, -4.
So vertical is up and down, horizontal is
Right or left. Okay? All right, now let's look at this. Suppose I ask you these questions. Suppose I just want you to tell me what the vertex is. Find the vertex. So here's the first one. Suppose I had f of x equal x squared minus 15. Just show me the vertex. So first of all, you got to determine whether it's a vertical shift or horizontal. Is this a vertical shift or horizontal? It's a vertical shift. So that's a vertical shift. Vertical shift is intuitive. You're subtracting 15, which means you could take the parent function and move it which way? Down 15. So instead of my vertex being at the origin, it's now going to be at 0,
15.
not 0, 15, 0, -15. All right, suppose I had this. Suppose I had x plus 7 squared. Notice that plus 7 is inside the parentheses this time. So that's horizontal. So that's a horizontal shift, and you got to think counterintuitive. So the vertex will then be what? -7, comma 0, because you're still on the x-axis, right? Whenever you're on the x-axis, your y value is 0.
So, number 2, you think counterintuitive, so it's the opposite. It's -7.
Yes.
But you use counterintuitive for the first one, and wouldn't it be the opposite of counterintuitive? If it's 15, it's 15.
But that's not 15, that's minus 15. You're subtracting 15. That's why you go down 15. Okay?
I'm seeing it now.
Y equal x plus, I'm sorry, ax minus 8 squared. Notice the way it's written, is that a vertical shift or horizontal? Horizontal. Okay, so horizontal shift, so you gotta think, okay, I'm gonna do this counterintuitive. So instead of the vertex being the origin, I'm gonna go which way?
Okay.
To the
Oh, to left, right.
to the right,
Oh, yeah, because the opposite.
because -8. You think opposite. To the right, how many units? 8. So what's the vertex? 8, 0. That's your vertex, okay? And then if you had y equal x squared plus 10, is that a vertical or horizontal shift? That's vertical. All right, once you find it, you can tell me the vertex. What's the vertex? Vertical meaning go up or down now along the y-axis.
0 and 10.
0,
Common
10. All right, now let's graph this one. So we're going to graph this. We're going to have the discussion again. So let's graph y equal x minus 2 squared. All right, so we're going to do it by, first of all, determining if it's horizontal or vertical. Is this horizontal or vertical? It's a horizontal shift. So, which means that instead of the parent function having the vertex at the origin, I'm now going to shift it which way?
Right.
To the right. How many units? 2. So what's the vertex going to be then? 2, 0. All right, now here's what you do, just like we did before. You plot the vertex. Plot the vertex. Once you find it, you plot the vertex. Now be a little bit careful, because here's what's going to happen. You could have easily made a mistake and done it the wrong side, right? But when you do that t-table, it should correct itself. You should then realize, well, I'm doing something wrong. Okay? All right, so you know the vertex is 2, 0, correct? So what you would then do is you would plot that point 2, 0, and then you would pick 2 points to the right, 2 points to the left. Okay? Now, before you go on, because you could have easily had all this mixed up and you would have said, well, I'm going to go 2 units to the left. Before you go on, let's check to make sure that what we have is correct. Okay? All right, so here's what I would do. If I'm saying 2, 0, right? Okay. So 2, 0. So let's check and see. If x is 2, the t-table, if x is 2, I get y equals 2 minus 2 squared. And what's 2 minus 2? 0. And what's 0 squared? 0. So I got y to be 0. If you had made a mistake, you would catch yourself. Let's suppose the mistake was this. Let's suppose the mistake was that I said the vertex was -2, 0. That's a very common mistake. Don't remember that. It's got to be counterintuitive of what I think. Let's say you made that mistake. All right? Well, let's check it. I'm saying x is -2, correct? I got y equals -2 minus 2 squared. But what's -2 minus 2? -4. And what's -4 squared? Positive 16, but that's not 0, right? So that would be where you would realize you made something wrong. Okay? So once you find the vertex, always make sure it's correct by just plugging it back in, and just make sure you get that same y value you think it is. So there's a vertex. Once you find the vertex, you pick 2 points to the right, 2 points to the left, and that'll be it. So and always go 1, 1, 1, 1. So if x is 2, now I'm going to let x be what? 3. Let x be 3. So when x is 3, I get this. I get y equals 3 minus 2 squared. What's 3 minus 2 squared? Oh, what's 3 minus 2?
1.
And 1 squared is 1. All right, now here's what happens. I plot the point 3, 1, and then I can find the other point. I went 1 unit to the right. What was my y value? 1. I go 1 unit to the left. In this case, x would be what? 1. What's my y value? 1. You just need 2 more points. This time, let x be 4. If x is 4, look how simple this is. If x is 4, I get y equals 4 minus 2 squared. What's 4 minus 2? And what's 2 squared? All right, I plot the point 4, 4. Remember, to get that point from the vertex, I went how many units to the right? No. How many units to the right did I go? No. 2. 2 plus 2 is 4. If I go 4, you're saying this. 1, 2, 3, 4. You're saying x is what? 6? That's not what we said. We said x was what? 4. So I went 2 units to the right. So I'm going to go 2 units which way? To the left. So that would be x is what? 0. And what's my y value? 4. And then you just draw your parabola. Do the best you can with drawing. Make it look symmetrical. And then notice I'm gonna do my transformation. So notice this was the parent function, the blue. To get what was it? Y equal x minus 2 squared. Y equal x minus 2 squared. To get that, I go which way? To the right 2 units, and that's what I ended up with. Okay? All right, so any questions on that? So use the idea of determining whether it's the vertical or horizontal, then determine the vertex and pick 2 points to the right, 2 points to the left. That's all this is. Now, next class period, we're going to look at the absolute value function. But you can do the same thing. You're going to find the vertex, 2 points to the right, 2 points to the left. The idea is the same, except the shape is going to be a V instead. Instead of parabola, it'll be a V. So we won't spend that much time on the absolute value because all this stuff that we just talked about is the same. Vertical shift, horizontal, find the vertex, 2 units to the right, 2 units to the left. But it will be a V this time. It will look like a V. Actually, it will look like this. See how it looks? That's the shape of absolute value. It's at V. But everything's the same. Right, left, up, down. Okay? Now, we're also going to talk about, next class period, we're also going to talk about the idea of function, what a function is, domain and range. It won't be that difficult. It won't be that difficult. All right, so what I want you to do now is this. I'm going to give you